Now that we can do more complicated derivatives, let's do a tangent line problem so with a slightly more complicated function. So what's a best local linear approximation of this function at x equals 4? I kind of gave away the punchline here. Best local linear approximation is tangent line, right? So let's write the tangent line formula. L of x equals, take a sec to try to remember the generic tangent line formula before I write it out. Okay, so it's f of c plus f prime of c times x minus c. What is c here? Well, we're saying let's focus at x equals 4, so we'll use c equals 4. Some people are tempted to type x equals 4 into Desmos, and that just gives a vertical line at 4, which does say where we're operating, but it's not really what we want to do. We really want to use c equals 4 here. So this is my generic formula. I need to make it specific for this particular function and c value. So I need to know f of c. So f of c is f of 4, which is 3 times 4 squared plus 5 times 4. What is f prime at c? Well, let's take the derivative. Derivative of 3x squared is 3 times 2x. The derivative of 5x is 5. F prime at 4 is 3 times 2 times 4 plus 5. I'm not in an arithmetic mood, so I'm just going to leave that alone. And now I can specialize my L of x to be f of c, which is whatever that was, 3 times 4 squared plus 5 times 4, plus f prime at c, which is 3 times 2 times 4 plus 5 times x minus c, so x minus 4. And I made a mistake in here somewhere deliberately, hoping you'd catch me. Have you seen it yet? Maybe pause and take a look. Okay, the trouble is right here, if I didn't put parentheses there, then the times would have only happened to the 5 and not the 3 times 2 times 4. So that is a tangent line formula. It's perfectly good. I haven't done the arithmetic yet, but the next thing I want to go do before I do any arithmetic is check it in Desmos, because if I check it and it's not right, then I know I don't even need to do the arithmetic. I need to go back and work on it. So let's switch to Desmos. Okay, we're here in Desmos, and I've got the function set up and colored blue because my main function is usually in blue. And I'm ready to start typing in what I got. So I got L of x equals 3 times 4 squared plus 5 times 4 plus 3 times 2 times 4 plus 5 times x minus 4. And did my tangent line turn out right? No, it didn't. That does not look tangent, and it doesn't even seem to be going through the value 4. That's at x equals 4. Oh, that's because I'm missing an x there. Okay, there we go. I can even put dot at c comma f of c. Oh, I forgot to define c. I'm using c equals 4. And let's color the tangent line black. Okay, so did my formula for the tangent line that I derived by hand work out? Yes, it seems to have worked. Can I grab this dot and drag it? Well, that's changing c, but my c actually didn't appear in my tangent line formula, so my tangent line wasn't getting dragged along with it. Here's something, a way that people sometimes accidentally fool themselves. Instead of typing this for L, they say, oh, well, I'm in Desmos, I can just type the traditional tangent line formula. This is another tangent line, and they'll say f of c plus f prime at c times x minus c, which is the traditional tangent line formula, but notice that it's plugging in c for f, it's plugging 4 into f, it's computing the derivative for us at f prime, just the individual, at c, just the individual value of the derivative, not the whole derivative function. It hasn't checked my work at all. This was my work. I can close that, and I'm still getting a good tangent line. So this is a good way of drawing a tangent line in Desmos, but it's not a good way of checking the work that I did by hand, because this is asking Desmos to do all the work. So as much as I want us to check our work in Desmos, we have to actually check our work and not just make Desmos do all the work for us.